Hello everyone, welcome back to Zenith Integral Academy, and in our last class we look at errors in measurement, a topic under instrumentation and control. So in today's class we are going to be solving questions pertaining to the topic, and let's take a look at question number 1. And we are given that in the course of the measurement of an industrial process, it was observed that the quantity Z is expressed mathematically as Z equals to 3Q raised to power 3 HA raised to power 4. If errors of up to plus or minus 1% are possible in the measured values of Q and H, while plus or minus 0.5% in the value of A respectively, we are asked to find the maximum percentage error in the measured value of Z. So let's solve this question. So we have our solution. Now we have our solution, and we write the data that we are given. So data given. Now we are given our formula, an expression which is 3Q raised to power 3 HA raised to power 4. Now we are given the error that occur in Q, H, and A. The error in Q is plus or minus 1% in Q, and that's the same thing as plus or minus Q all over 100. Similarly, the error that occur in H is plus or minus 1% in H, and that's plus or minus H all over 100. This percentage means over 100. And the last, which is the error that occur in A, and that's plus or minus 0.5% in A, and that's going to be equal to 0.5A all over 100 plus and minus. Now we have this. So we want to find the maximum percentage error in Z. So we generate a connecting formula. So we generate a connecting formula using small increment error, since it is expressed in percentage. The small increment error. So we are going to be having the error that will occur in Z to be equal to the error that will occur in Z to be equals to dz all over dq dot dq plus dz all over dh dot dh plus dz all over dA dot dA. You can see now that we have dq, we have dh, and we have dA, but we did not have dz dq, dz dh, and dz dA, and we can equally get that using the knowledge of what? Partial differentiation. So let me call this 1, let me call this 2. So you can now say from equation 1, which is Z to be equals to 3Q raised to power 3 HA raised to power 4. So you can say what? Using partial differentiation. So if I should differentiate my Z with respect to Q, I'm going to be having this 3 will multiply this. 3 times 3. You subtract 1 from the power, you have 2. Then you write back your other variable, they will assume constant. So I'm going to have 3 times 3, that will give me 9Q square HA raised to power 4. Let's call this A. So similarly, you differentiate Z with respect to H. The power of H is 1. So 1 times 3, that will give us 3. Then you subtract 1, 0. Anything is power 0, 1. Then you write back your other variable, which is Q, then A raised to power 4. Call this your B. And you do the last, which is dz all over dA. And in my A, 4 will multiply this 3, which is 3 times 4. You subtract 1 from the power of 4. It will left with what? A raised to power 3. Then you put your other variable, Q raised to power 3 and A. Then you can rearrange 4 times 3, 12. you rearrange q raised to power 3, then h a raised to power what now? 3. You rearrange, then this is your what? Your c. Since we have this, now let's take a look at our connecting formula. We need dz dq. We have dz dq already. We need dq. We have that as well. We need dz dh. We just did that. And we need dz dA. We have that with respect to dA, in which we already what? We are given. So substituting each of these values into my equation 2 now. So you say input A, B, and C into equation 2, which is our connecting formula. So this is what we are going to have. So the error that will occur in Z will be equal to dz dq. And what is my dz dq? 9q squared. So I have 9q squared h a raised to power 4 into bracket. According to the formula, I have dq. And what is dq? Dq is given as plus or minus q all over 100. So I'm going to have plus or minus q all over 100 plus, according to the formula, I need dz dh. And dz dh is what? 3q raised to power 3 a raised to power 4. So I'm going to have 3q raised to power 3 a raised to power 4 into bracket plus or minus h all over 100 as well, then plus dz dA. And my dz dA is what? 12q raised to power 3 h a raised to power 3, while dA is expressed as 0.5% in A. So I'm going to be having 12q raised to power 3 h a raised to power 3 into bracket plus or minus 0.5a all over 100. So I'm going to have my dz to be equals to, so the q will come out and multiply q, and that is q times q cube. Then the 9 will go inside the bracket. So if q should multiply q square, I'm going to be having q cube h a raised to power 4 into bracket plus or minus 9 all over 100 plus the h will also come out here. I'm going to have q raised to power 3 h a raised to power 4 plus or minus, then the 3 will go inside the bracket, then plus the 12 will multiply the number, while a will go and multiply its own variable a times a raised to power 3. That will give us a raised to power 4. So I have q raised to power 3 h a raised to power 4 into bracket plus or minus 12 times 0.5 all over 100. So I'll have the error that will come in z, the z to be equals to. Now when you take a look, you can see that we factorize. Q raised to power 3 h raised to power 4 is common in both. So I can bring out the common what? The common factor out. So you factorize, and that's going to be q raised to power 3 h a raised to power 4 into bracket. Similarly, plus or minus, plus or minus, plus or minus. You can just say plus and minus one side. Then I'm going to be left with 9 all over 100 plus 3 all over 100. Then plus 12 times 0.5. That's going to give us 6 all over 100. And now when you take, I have q raised to power 3 h a raised to power 4 to bracket plus and minus 9 plus 3 plus 6. The LCM of this is 100. So, and that will give us q raised to power 3 h a raised to power 4 dz, then into bracket plus and minus, that will give us 18 all over 100. But mind you, we shouldn't forget that my z is what? 3q raised to power 3 h a raised to power 4. But what I have here is q raised to power 3 h a raised to power 4 of 18. If I should bring 3 to the 4, that is, I want to have something like this: 3q raised to power 3 h a raised to power 4 into bracket plus or minus. How many 3 can we see in 18? That's 6. Meaning 3 times 6 will give us what? 18. So I break down this 18 down in form of this 6 times 3 all over 100, so that I can be having my original question back, which is z equals to 3q raised to power 3 ha raised to power 4. And since I know now that this is the same thing as what? Z. That is 3q raised to power 3 ha raised to power 4 is the same thing as what? Z into bracket plus or minus 6 all over 100. Then I can say the z is equals to z into bracket plus or minus 6%. So meaning that the error that occur in z is what? Is 6%. So you comment and say there is error of plus or minus 6% in the measured value of z. Thank you very much. So I will also solve another aspect of it in our next tutorial video. Thank you.